Hello guys, welcome to this channel. And my name is Danny. And today we're going to talk about flow patterns with streams. So before that, I hope you guys doing great in this new year of 2024. And we have finished talking about 4 types of stream. So before we jump into the new session, I would like to give you a review of what we talked about. So there are 4 types of streams we already talked about, and so you can see here in this slides we just give you a summary of these 4 types of streams. So the first one is a readable stream. So you can see that you should use push method in your underscore read method to read your data from the underlying resources, for example, from your file system, a specific file, and then the data will be into your readable buffer, readable streams buffer. And then if you want to use this chunks of data, you have to define your readable right here. You have to define your readable event for flowing mode reading, and read method in read event for non-flowing reading. So that means you can leverage readable stream to read some underlying data or chunks to your application without touching the underlying resources. And for writable stream, you can see that here your application just wanted to write some data to underlying resources via writable stream. So you use write method to write your data into, or you write your chunks to the writable streams buffer. And then writable streams will use underscore internal underscore write method, or you can give underscore write to truly write your data to the underlying resources. So that's the readable and writable streams. And we also talked about a transform stream, which is a special or particular duplex stream. You have to give or carry out or implement underscore transform and the underscore flash for your transform stream. And pass-through stream is special type of transform stream which can be used as a placeholder and a flow monitors. So I already gave some of the examples for how to use a pass-through streams to be your placeholder, or to as a lazy pipes, for example. So another tool worth noting that we noted that there's a pipe statement or a pipe you have to master. So how do you pipe, where the signature of the pipe method is readable dot pipe, and it takes in the destination pipe, which is which is a writable stream. So readable.pipe then returns a writable stream. So you can have a chain of these pipes if your returned value is duplex stream or transfer stream, because if you want to chain your action, or if you want to chain your pipe, the return value will be readable, right? So that means destination is writable and the return value has to be a readable. That means this object will be a duplex or transform stream. So that means with that you can chain you a lot of pipes to for your convenience. So we also talk about pipeline, how to use pipeline, how to so to facilitate your error handler code. So that is for the review, and we jump to our today's session. So as we've seen, so stream has a lot of function and features, and you can leverage, and the streams can be used as a design pattern for you to solve some common problems, to encapsulate some of the hidden. So you want to hide some of the specific actions or algorithm. You can use this design pattern by using the stream instead of directly controlling your underlying resources. So that means there's a encapsulation within the uses of the stream. So here, another thing that I want to mention, or just worth pointing out, that so because the node is very known for asynchronous control or asynchronous snippets. So how do we leverage stream to carry out or to fulfill some of the asynchronous control flow? So that's the purpose of, or the need of this session. So if we look at the asynchronous control flow, or if we look at how we running the tasks, for example, running everyday routines, we have some of the common sense on this. So there are different types of execution or task execution. The first one is sequential. So every task will be in the correct order. So you finish the first one, then you start the second one, and then you start for the more tasks in the future. So everything will be in the sequence. So that's called a sequential execution. So because if you look at the pipe method or pipeline, if you look at the mechanism of the stream, so streams are natively support. So asynchronous or a sequence execution is natively supported by streams, because if you look at the stream trunk, the structure of the internal trunks, so the data or trunks or internal buffer now be organized or manipulated in sequence. So their sequence number or some of the remaining or rest of the length of remaining buffer, for example. So those are things are related to sequential execution or a sequence of the data. So another things, or the other side, we can see that the relations among pipes. So for example, we just hook up a lot of pipe into this pipeline. For example, we have data.csv, and we wanted to have a CSV parser, and then we just I want to filter this data by country, then give aggregation by workout is the summary of the profit, then we give it an output. So that means we just organize this pipe. Those pipes are natively sequential or in order. So just we already gave a lot of examples of how to organize this pipe, how to write up this pipeline. So in today's lesson, there's no more example for sequential execution. So another type of task execution is parallel execution. So we talk about parallelization or concurrency. So for example, let's say we have 4 tasks here. We want these 4 tasks running at the same time or almost running at the same time. So we put these tasks into the execution machine or this execution node. Then this execution node will be running for you tasks. Please notice that the order of input task is not necessarily the same as the output of the order or the output of the task order, because we just guarantee that we have a right order when the task into the execution node, but every task takes different time to finish themselves. So the order of the output is not necessary to be the same. That means we call it an unordered parallel execution, because the output is unordered. Some of the tasks just will be comfortable or will be satisfied with this unordered parallel execution. And also there's a variation for unordered limited parallel execution, because there's a limited added here. So every execution node had this capacity had its own capacity. So that means the maximum order, maximum concurrent tasks, the current concurrent number of the tasks will be limited. So for example, there's a 4 maximum task will be 4. So when the number 4 was reached, we have to pause until the execution node has finished those all of the tasks. Then the fifth task will be coming in order. Another 4 will be coming into the execution node. That means the unordered limited parallel execution. And we also have another requirement from real life or from a program request. That means order parallel execution. That means the output, the input, the order of the input is the same to the output of the order of the output. That means we have to keep the order while the execution, while the task are executed. So let's give in today's lesson, let's give you a snippet on how to fulfill a unordered parallel string. Then we'll move on to limited or parallel stream and ordered limited parallel stream. So this is a simplest one for parallel stream, because when we start this kind of like a design pattern, so our snippet becomes more complex as compared to the previous samples or snippets. So we have to zero in on it, and hopefully I can clear things up and give you some of the tips and inspiration. Here we have this parallel stream.mgs, and the objective of this program is to probe some of the HTTP web server. For example, here a list of the HTTP web servers are given, and the program read this urls.txt as the input, and then the program will probe all of the web server to see if it's up or down, and then you give it a result back. For example, some specific web server URL is down, some specific website is up, those kind of things. So because of these URL or web servers are discrete or separate, so we can start all of the tasks almost in the same time. So we just use this parallel stream as a design pattern to finish this quiz or finish this task. So let's scroll down to the main program first. The main program just consists of one statement, which is pipeline. We just we've organized this pipeline with our streams. For example, we create read stream from our URL s.tst I mentioned before, and read this stream. Then we just manipulate this stream's data and change it to the node object, or change it to non-array. So split the read stream into an array which this array is the one of the lot of URLs. And then we just followed by a new parallel stream. This is our key part for this program. So we just create our parallel stream and give a function here, a synchronous function here. And this is a synchronous function here. Right here. This block is a synchronous function to be given to this parallel for to initialize this parallel stream. And then when we have all of the output or result, I just put the result into the results.tst. So here we have three streams. One is a readable stream, and the middle one is the parallel stream, which is we are going to create, and then followed by the writable stream, which is we want our result to be written to this stream. So that's the main part. And scroll up, we just elaborate on the parallel stream definition, this class definition. So parallel stream that are inheriting from transform, and then we just here we have constructor. So in this constructor, it takes user transform, which is our asynchronous function. User transfer is a asynchronous function, and options just very basic option for the stream. So here is super, and we just put this stream into a object mode. This is true. Object mode is true because we want to because the input of this parallel stream is an array of URLs. string of URLs. So we just set this parallel stream as an object mode, and this is remaining options here. So we put all these options into the super to initialize the whole class. And then we just add some our own property here. For example, the main program gives us a user transform asynchronous function, and just put this function into the user transform property. And there's a dot running, which is the number of the total running tasks. And here we have a terminate callback for us to terminate to do some cleanup. And then we have our important underscore transform internal method. Because when you instantiate your parallel stream, so underscore transform will be automatically invoked. So here we have our main logic here. So when we finish in initializing our parallel stream, and then that means that every tasks or every probing tasks. Remember, we have to probe every website to see if it's up or down. So that means that when every task goes into our main program, so we just initiate or initialize a parallel stream mapping to the task. So here we just add the number of total running tasks because we have our new task coming in, and then we just console log this to show us our time step here, and also a URL string. The string of URL will be shown in on the screen. And this is this style user transform, because user transform is synchronous function. So at this point, we just calling this function, let it run. So this asynchronous function takes a trunk. This trunk is URL string, and the encapsulation, which is UTF-8, and this push bound this. So we just transfer this push, this streams push method to this function as one of the argument. And this style on complete is also another internal method, just given to the asynchronous function to be executed in the future. So then we give it done then function, because then must be called if you don't call this then, so the transform stream will be passed. So underscore transform, you finish all your tasks, and then the last line you have to write done to run done. This is callback. This is underscore transform callback. And then underscore flash. Underscore flash is a when does it call this underscore flash? So when the transform stream have no more data to be written, and then the underscore flash will be called. And in the same, the underscore flash also had the same, also had the done as a callback. You have to call this. And here we give the console log and the timestamp here, timestamps here, and also here's the condition. If this running the value of this running is greater than 0, that means they are some remaining tasks are still running. Then you just give this done, which is a callback, internal callback to our property, the terminate callback. And then if this running is equal to 0, and you just call the done. What does that mean here? So that means that if you have some that might be easier when we got some of the output, and then we just get back to talk about get into this to talk about this again. What did that mean? What did that mean for this a condition here? And we also give underscore destroy as a routine. So we just super destroy and the console log this destroy as a routine. And also here's one more things underscore on complete defined here. And when the task, when the asynchronous execution, asynchronous function has finished, then that means a task, the task has been finished. So once the task has been finished, or once the probe of web server has been finished, then we have to call this this block. So for example, when one of the tasks has been finished and the running, the number of the running tasks will be decremented by 1, right? And also console log the task, a specific task has finished at the time step. And if there's an error, just the immediate error event. If there's no error and this running task is equal to 0, and we just call this terminate callback. Remember, we just showed you that we just give this terminates CB, a done, right? Here. So that means that when the running task is not 0, we still have a lot of running task left. We never call this terminated callback. We never call this done. So that this transform stream is still alive because we didn't call this done. So whole transform will be paused if we did not call this done. That's the little bit, little bit difficult to understand this, but if we give you some of the output, or if you have some of the practice, you can touch on it and get across. And then, yeah, that's the whole definition of our class. And then we just run this. Here we already run several times actually, and we can look at our this output. Firstly, we just look at our initial website lists. Here we have 7 URLs in this file. So we read these files and split it into an array consisting of these 7 URLs. And then we push this array, or push every cell, every item of this out of the array to our parallel stream. For example, the first one, this http mario.fyi as one trunk was pushed to this parallel. And then well, let's move on, scroll up to this construction. We instantiate this program, this parallel stream, right? So we takes in the user transform, this function, and then we, as I said, we just create this new object for URL, for task. Then the underscore transform will be triggered or called, and the task of running will be added by 1. And then we just in transform a console log, in transform this string and this timestamp. This timestamp is measured by millisecond. So it just remembers the 2020, 60 millisecond. And then we call this asynchronous function. Trunk will be this string. Encapsulation will be the default UTF-8. And this push is a push function. It's internal transform, internal push. And this under complete. So that means we track this function to its own function definition right here, asynchronous, and it takes 4 arguments, right? URL is our URL, this URL, and try this block. So we just launch fetch action for this probe, for this probing by using the HTTP header method to probe to see if this Mario.fii is alive or not. So the timeout will be 5 seconds. If it expired, so we just give a abort signal. It's an error. It's an error. So we enclose this block in the try block, and if there's any error, we just push this URL is up. That means this website is alive without any error. If there's an error, we just push is down. This URL is down. Push is our transform streams dot push. So that means we push this string into our transform streams readable buffer. So, and then we just after that we just call the then URL, because we have to do some cleanup task. Then will be underscore incomplete. So here there's no error, so we give none. That means there's no error. So it just trunk will be this string, this URL, string of this URL, and this running will be decremented by 1, and the console blah 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 blah, and give some cleanup function. And because we read this urls.txt, we read very fast. We read very quickly. So all 7 tasks will be initialized almost at the same time. If you look at this time step, you can see 23, 29, and the first one is 2260. So within less than 100 milliseconds, all 7 tasks have been read and have been initialized. So all that means we just build a parallel task or parallel stream. You can see here 7 tasks will be running at the same time, almost at the same time. And here in underscore flash has been triggered. And 7, this is running value of this running is a 7, that representing there are 7 tasks here, and this is a time step. So that means underscore flash will be triggered when all of the written data has been written. So we just write up all of the URL s.tst's content. So the underscore flash will be triggered or will be invoked. And then because we launched or we already yield 7 asynchronous snippets, which are running almost at the same time, start running almost at the same time. But because it takes various time to finish the probing, so the time of the completion will be various. You can see that it's 2894 is 4330. The last one is 5088. So you can see the duration of those asynchronous tasks will be more than 3 seconds. That means that so when we finish every asynchronous task right here, because await every synchronous task here, we push this, we have different time step. We have a different point in time to finish the whole probing. So the result, the order of the result will be different than the original one. So that's the simplest parallel stream without restriction of the order. That's it. That's this whole logic of this program. Hopefully it is a little bit complex, so hope you guys can just practice it and look it again, and just hope you guys just I explained it clearly, and if you have any question, just leave it in the comment, and also give this a snippet in the to give you another article, and so including the whole snippet. Thank you, everyone, and until have a nice day, and until next time, see you.